Welcome to the ReAutomated podcast, where we explore how automation is redefining manufacturing. I'm your host, Chris Savoia from Universal Robots. Today, we have a special guest, Brian Gerkey, from the former CEO of Open Robotics and now the CTO of Intrinsic. Brian has been a pivotal figure in the robotics industry, and we're excited to dive into his journey in the innovations at Intrinsic. Brian, thank you for coming on.
Oh, thank you, Chris. Very kind of you to have me here.
My pleasure. So Brian, you've had a remarkable journey from founding Open Robotics to becoming the CTO of Intrinsic. Can you share what motivated you to transition to Intrinsic?
I don't know about remarkable, but I do count myself as fortunate for the opportunities that I've had. We founded Open Robotics in 2012, and we ran it for a decade. And really had, I think, a high impact, fantastic run. We were working with a lot of different government agencies, a lot of commercial companies, and helping them to extend and apply all of this open source software that we had developed throughout the ROS ecosystem. Along the way, we kind of stumbled into a business model, which was essentially, we were selling engineering services on top of an open source platform, kind of an old business model, not a surprising way to do things. But I also saw along the way kind of the limits of the way that we were pursuing our mission of getting this open source software out to be as widely used as possible. And what we saw with Intrinsic was a like-minded organization that was also setting out to build a software platform that could be very widely used throughout the whole industry. But they were building a lot of things that were kind of complementary to what we had built in ROS. They were building a lot of the back-end infrastructure. They were building a lot of the web-based developer tools. They were building a lot of the deployment pipeline. And we felt like if we were to take the best of both of those worlds, if we were able to take this very broadly used open source kind of toolkit of libraries and put it together with this infrastructure and set of tools that we could have a bigger impact together. And so, we took that bet back in 2022, and 2 years later, I'm still very bullish about where we're headed.
Yeah, that's awesome. Yeah. Just for our guests, Open Robotics has been instrumental in the development of ROS. And for those that don't know, ROS is short for Robot Operating System. And it's kind of like an open source middleware that provides software packages for developers to create robot applications. And ROS was very instrumental in taking advanced PhD level concepts in robotics and making them accessible to more people through those packages. And I think robotics wouldn't be where it is today without things like ROS, because like I said, it really makes the difficult easy for a lot of people. And now ROS has over 1 million developers, in large part due to a lot of the work that Brian has done. So just to clarify, how do you see the convergence of ROS and Intrinsic together shaping the future of robotics?
Well, and I mean, just to touch on ROS a little bit, I think you're right. Having over 1 million users by the best of our ability to count them, everywhere you look, you see ROS, right? You see ROS in the form of robot arms, robots on legs, robots on wheels, robots that are flying, robots that are floating, swimming. NASA runs robots on the space station that have ROS inside. So, very, very widely used. But again, I think there's yet more to do. I think one of the biggest blockers to having broader utility for everybody coming from robotics and automation is making it possible for people who have the most valuable, useful ideas for what the robots can do to be able to come in and build those applications. And we made, I think, a big leap forward with ROS. Like you said, it makes the difficult easy in the sense of taking care of a lot of the underlying things that everybody needs to do to build a robot and encapsulating a lot of the existing algorithms, for example, so you don't have to re-implement them yourself. But there are still parts that if you go look at all those companies that are building ROS, building products using ROS, each of them is still also redoing a lot of the infrastructure to be able to actually deploy a product and support it and do updates of their software platform and offer a scalable developer interface for people who want to maybe not just take the product as is, but think about it as a piece of flexible automation that they want to be able to modify. So that's where we really see the convergence of what we built together with ROS coming together with what has been built over the last several years at Intrinsic, where if we can do this right, then we think that we can actually make it possible so that if you've developed, a system using ROS and you want to go deploy it, you've got a great idea for how to roll out, your company, but you don't want to have to build all the rest of it that doesn't come in the box with ROS. We think Intrinsic has a compelling platform offering that you can basically shift onto that would make you much more successful much more quickly. And we think if we do that right, then there's, while ROS, yes, has been very successful, we think there's actually a lot more to do. I mean, we've been waiting for the robotics revolution since I've been in this game since the late 90s. And we've seen in the last, 15 years, we've seen the rise of AMRs, we've seen the rise of collaborative robots, but still you go looking for automation out in the world and it's still, relatively little of all the things in the world that can be automated in a useful way that would help society and increase productivity and take drudgery out of people's lives. Relatively little of that has yet to be automated. And there's that's in large part, I think, because it's still too hard to take a lot of these existing tools and apply them. And, what we're really doing here is trying to tackle that problem from a software perspective. Again, bringing together the best of this great big open source ecosystem together with these more sort of industrial grade development and deployment tools that we've managed to build at Intrinsic.
Yeah, that makes a ton of sense. It kind of brings me back all the way to the first episode we've ever had on ReAutomated. We had a guy named Ben Armstrong from MIT on, and he talks a lot about this concept of positive sum automation. In one of his theses is that you need to be able to put kind of the automation in the hands of the domain expert in order to really crack the market open and being able to deploy automation. For a long time, automation was gate kept by automation engineers, or there was this need to kind of have this translation layer where you're taking the domain expertise of whoever is actually in charge of a process, whether it's a manufacturing process or a logistic process or whatever, and then you have to kind of run it through an engineer who translates it into automation. But the more that you can take automation and lower the barrier so that you can put the hands in the domain expert, the more applications you'll be able to.
I couldn't agree more. I mean, the very surest way to end up with a flop of a product is to have a robotics engineer come up with the use case, right? Like, we love robots, right? We're going to look for a way to use a robot somewhere for the sake of using a robot. And we're super passionate about it and we're going to work really hard on it. But boy, the chances that we as people who are pushing the technology know what the right problem is to solve are pretty slim. So yeah, more with you've got to connect with the domain experts, with the users, and have them be in the driver's seat. And you think about this as you roll out. We think about this from the Intrinsic perspective of trying to put more advanced automation in the hands of people in, let's say, manufacturing settings. There's a huge amount of knowledge that is in the heads of the people who are in the facilities. They're designing the automation processes. They're on the shop floor, actually operating the systems once they're out in the field. And you can't deploy any of this technology in a remotely useful way without not only connecting with them and understanding what it is they need, but like you said, actually giving them agency, giving them the ability to really control how the system is used. And that's where, if you imagine you're just going to go drop in a quote unquote autonomous robot and expect it to work well, I think that's a bit of a pipe dream, right? What you're actually doing is putting a system out in the world that is going to interact with not just other robots and infrastructure around it, but also all the people around it. And a lot of those people, like you said, are domain experts, and you have to be able to leverage that expertise to get a valuable output from it.
Yeah. I believe that robotics is still kind of yet to have its Windows moment, meaning, Windows was part of that personal computing revolution. And when it broke open, it really democratized personal computing access to consumers in everyday life. And so what do you believe when do you believe robotics will have that moment? And what do you think is the key to really sparking that?
Yeah, and I think it's fair to say that like ROS maybe created the Linux moment where we with ROS we created a very powerful, but also I think it's fair to say kind of famously difficult to learn how to use SDK for building robot applications. It's not uncommon to walk into a lab today and find folks who are they're most comfortable using Windows to do most of their work, but then there's a machine where they've installed Ubuntu Linux because that's the one where ROS is best supported. We also support it on Windows, but you really have to. ROS is kind of a system where you come to leverage in order to leverage what it offers. You have to come meet ROS where it is, as opposed to the reverse. Yes. And I think what the next step is then to take that underlying infrastructure, which is super powerful, and make it more accessible. This means making it using modern technology to make everything cloud-backed, make it all web native, make it possible for people who maybe don't know how to program to author robot applications, go start exploring low-code and no-code environments, start taking some of the more sophisticated capabilities that are out there and packaging them up in a way that you can just use them without needing to understand, I should say, how they work internally. And I think we're getting there. I think there's actually we're starting to see some examples where you can take some of these really much more advanced sort of AI capabilities and make them accessible to people in a way where they can get value out of them, but they don't need to know how they work internally or even parameterize them.
Yeah, that you just read my mind. That was going to be my next question. So Intrinsic is building an AI powered platform. So with everything you've said about building on the open source ideals, but making them more productized and accessible to people, where does AI come into this? And can you give an example of actually using AI in an application on the Intrinsic platform?
Yeah, absolutely. So, if you use the Intrinsic platform today, then all of the perception is powered by AI. And I'll also mention I feel obligated to mention that a lot of the things that we don't think of as AI today, we called them AI, and then they started working really well, and then now we don't call them that. And there's the very latest, the cutting edge of AI is now what we call AI. To me, it's a very broad bucket. But if you're talking specifically about sort of like modern generative AI or foundation models, these are things that we're applying today in perception, in particular, because it's one of the most straightforward use cases. So if you think about a robot, it's got sensors, often cameras, maybe 2D cameras or 3D cameras that give you depth information, or even cameras that give you they view the world in other spectra. And you want to make sense of that environment. You want to take in that high volume data and then understand what's happening. You want to be able to pick out the objects you want to interact with, see where they are in the scene. We've built a whole pose estimation pipeline, which is to say, if I look at an image, I can find out where the objects are in the world, and then use that information about where they are in the world to, let's say, command a robot to go and pick them up. Right, the thing you might want to do with a robot system, and that capability has existed in the lab for several years. I think we have a very cutting edge implementation of it. But this is the kind of thing that you would have seen videos and papers on this kind of technology going back several years, maybe even 10 years if you were, depending on how you define it. I'd say the key thing that we've been able to do over the last couple of years in Intrinsic is package that up in a way that it's a reusable service. If I want to build a robot application, I can just drag in the pose estimation service and say, I want you to tell me where all of these objects are in the world. And for that object, I can just give you a CAD model. We have a whole automated pipeline that in the cloud, which will train this pose estimator. And then it just works. And what's behind the scene is actually, I mean, frankly, you're resting on the shoulders of giants, right? What you've got there is the result of decades of cutting edge research that goes back a really long time. But we've managed to basically encapsulate all that in a system that just runs in the cloud to train it. It actually runs next to the robot when you execute it. But importantly, as a user, all I need to know is that's a thing where I want to know when when I want to know where an object is in the scene, it's just a widget that I get to use. But behind the scenes, it's magic.
I appreciate you taking the care to break that down in the way that you have, because we've probably had 4 episodes dedicated to AI and robotics now on this podcast. And I still think that at times it's confusing. It's really interesting to hear you kind of talk about how you're right. Like AI is oftentimes considered the leading edge of like generative models that we have right now. It does certainly date back. It makes a ton of sense to deploy it in that easy to use way. Do you guys use your own models for these things, or do you train? Do you transfer from some like larger models out there, or generally like what's your approach to these kind of things? Because I know the field is progressing so rapidly, so you have to just stay at the forefront of it, right?
Yeah. So we think about it. Well, first of all, we use all the same common underlying infrastructure that everybody uses. There's a well understood set of largely open source libraries out there that people use to implement these sorts of learning models. We think about it from 2 perspectives. One is that we've got a team in-house which is expert at building these kinds of systems. And so what we do is we build our own networks, we build our own data generation pipelines, we do a lot of synthetic data generation and simulation. We are able to train those systems. And then that's kind of what we think about as that's that post-estimation capability that I just described. But also, importantly, Intrinsic is, for this to work, we can't build all this stuff ourselves. And so we also think about what we're building as being a place for others to bring their models and run them. So I've just described one use case for perception, but let's say you come in with, you've managed to train a model that it doesn't just tell you where the objects in the world are, but it takes an image and then it goes directly to controlling a robot arm to go and grab the thing, and it skips all those intermediate representations, right? This is actually a very active area of research right now. It can go build more of an end-to-end model. That's not, we're not working on that right now, but if you're working on that, we'd love to give you a place to drop in the result of your work and have it execute in a way that could be rolled out as a kind of a commercial application. And we think there's a lot of value there, because a lot of the experts who are able to go deep and build these cutting edge systems, they are rarely the people who are also in a position to build everything else that's needed to deploy that result. And so what you end up with is really compelling demos, really compelling videos, seminal papers, but there's a step that has to come after that to capture that result and get it out to the world so that engineers and operators and facility managers can have access to it.
Yeah, totally. That makes a ton of sense. So maybe like a direct question, there's been a lot of, Intrinsic is building an AI platform, but there's been a lot of robotic platforms developed over the years. And recently, if you follow the news, we saw ReAutomated, for example, shut down. So what do you think succinctly, what makes Intrinsic platform different than some of these other platforms we've seen in the past?
Yeah, I never had the opportunity to try the system that Ready was building. But I've seen a lot of robot platforms over the years. I built my first robot platform in the mid '90s, and have worked on several since then. I think what I would argue is, setting aside what we're doing at Intrinsic, is, and this is where we can lean pretty heavily on the heritage that the project has coming out of Google. Intrinsic is a separate company, but it come out of Google, is really an emphasis on the industrial grade infrastructure that you need to do everything from cloud-based development through to secure deployment with the support for over-the-air updates, where we're thinking about we're thinking about security, we're thinking about privacy, we're thinking about compliance with relevant standards. Like these are things that just building that kind of backbone that you need in order to have a scalable way to roll out software to where what we hope will eventually be, a vast population of robots running this software. It's not a trivial thing. And that's why it's taken, a fair amount of time and a fairly significant investment to get to the point where we're ready to roll it out. So I think it's like, it's much more common to focus on the specifics of a near-term application than it is to take the time and build all of the underlying infrastructure that is really needed to make it successful in the long run.
That makes a ton of sense. And Google affords you the ability to have that. Like startups can't afford, honestly, to invest in those kind of scalable strategies a lot of times, right? They're under the gun. So that makes a ton of sense. Universal Robots is owned by an S&P 500 company called Teradyne. And I feel the same way about them too. They bring a lot of maturity to Universal Robots and scalability that I don't know that we would have had otherwise. It gives kind of a lot of legitness to the company in some way. So I feel you on that.
Having that kind of corporate support that's willing to take the long view and, be willing to invest in things that are a little more speculative. It's usually not something you can do in the early days. Even Universal in its own early days wasn't in a position to take those kind of long views. But after a series of bootstrapping, you were able to get to the point where you had enough success that you were able to find somebody in Teradyne who can go with you on that longer journey.
Yeah, totally agree. So let's talk a little bit about open source and proprietary. So you founded Open Robotics with open source ideals at its heart. How do you preserve these ideals at Intrinsic while balancing proprietary development and needing to commercialize products?
Yeah. So first of all, we continue to invest directly in the open source development. So I've a pretty sizable group of engineers in my team who are spending all day, every day doing open source development. They're contributing to ROS, they're contributing to Gazebo, they're contributing to the other open source projects in that ecosystem. And in fact, there's actually more investment going into those projects in terms of just direct roadmap development than we were able to do previously at Open Robotics, where we were spent most of our time. It's not something that, the public, I think, generally well understood at the time, but we spent most of our time at Open Robotics really serving the needs of direct customers who were coming to us with projects. And what we were able to do is take a little, we were able to shave off a little bit here and there and work on the roadmap items for ROS. We've got more ability to do that now. So that's actually a good thing. And I hope that I believe the community is seeing the benefits of that now with some of the things that we've been able to land in ROS recently. The second thing that we're doing is really, Intrinsic doesn't invest in ROS out of altruism, right? And if it did, that would be a fragile situation. We invest in ROS because we think that there's a legitimate business opportunity there. And so what we also do is work on merging the work that's been done in ROS with the work that's been done at Intrinsic, so that, at some point what I'd like to see happen is that the product offering coming out of Intrinsic is really, it's using and building upon ROS in a way where it'll just perennially be in our own self-interest to continue to invest in that underlying open source ecosystem. And in this way, we're not inventing anything new, right? This is the history of open source development. You have companies all over the world who have built their own products where there's a proprietary aspect to it, which is not uncommon in order to be able to have some kind of moat that you can use to protect your business model. But it builds on an underlying open source base, and you make the judgment that you'd rather than either build that base alone or modify alone, you'd rather be willing to contribute back to it in an open way, and that's what we do.
Yeah, that's fantastic. It makes a lot of sense. I am biased, of course, but I think that Universal Robots has the best driver for ROS of any industrial arm out there. And I know that we're kind of launching a new generation of our software called Polyscope X. And a large part in how Polyscope is architected, it actually uses a lot of ROS ideals. It uses ROS topics, and you can publish and subscribe things as well. So I think Universal Robots is right there with you in terms of embracing this as a technology for the future. And together, the sum is much greater than the individual parts, for sure.
That's really great to hear. And I finally remember back when I was at Willow Garage, when we were, it's still in the early days of developing ROS, we built the PR2 robot, which is the first robot to run ROS. But it was still, very far from having critical mass in the community. And I remember contacting my old friend, Esben Ostergaard, from Universal, to ask him if we could get a UR5, and he managed to get us one. And then I had one of the engineers on my team build arguably the very first ROS driver for it, but we definitely built it ourselves, and we just used the publicly available documentation. And it wasn't something that Universal, and this was very common at the time. You didn't see a lot of the hardware vendors really thinking that it was in their interest to have a ROS driver. It was like, well, okay, if people want to use it in that way, that's fine. But now that's really shifted, because now I suspect you, as many other companies, are seeing many of your customers are saying, well, that's how I'm going to use the robot. And so you'd rather have it, the robot ship basically with a very high quality driver, because that's how you expect a lot of them to interact with your product, and you want them to have a good experience.
Yeah, especially those kind of OEMs or people who are building their robots into completely finished applications, oftentimes running the robot headless. It's in our best interest to maintain that, because it allows us to, have better longevity on the robots. They're being controlled in a way that the engineers can actually test for in Denmark, and it results in a much better experience for everyone at the end of the day. So that's a really cool story about Esben to hear. It's amazing how much his influence is still touching everything about Universal Robots to this day. So let's talk specifically about something called ROS Skills. So what are ROS Skills, and how do you think that they can lower the barrier to automation? Will open source developers be able to contribute to ROS Skills, and where does Intrinsic play in helping developers commercialize ROS Skills?
Yeah. So first of all, the skill concept is that's a term that we use at Intrinsic to describe a reusable chunk of code that is executable on our product, which is called flow state. So I'll jump straight into that. So flow state is it's a tool for doing end-to-end application development, primarily for robots in robot arms in a manufacturing context. So taking, UR is a well-supported robot within flow state. And if you want to go, we basically cover the whole journey from being able to design the 3D environment or import it from a CAD system that you've got for how the work cell, to authoring the application, which you can do. You can do it graphically if you're not a programmer, but you can also write code to represent it, through to doing testing the application against simulation, which uses Gazebo, by the way, open source simulator coming out of the ROS ecosystem in a cloud environment, to then being able to deploy that resulting system that you've tested to a computer that'll run and talk to the physical robot. So that's what flow state does. In there, when you're doing that programming part where you're building your application, we have a behavior tree model of programming, which is quite common these days. And you've got these blocks in there. And one of the types of blocks you can put in there in that behavior tree is a skill. And a skill can wrap up just about any kind of capability that you want to put in there. It could be anything from very simple to just, checking the state of some simple sensor, to doing something like pose estimation, like I described earlier, where inside that skill is actually something quite complex. So when you talk about a ROS skill, this is the way that we're bringing the best of ROS into what Intrinsic is built in the form of flow state. So a ROS skill for us is a way for you as a ROS developer to package up the, part of your ROS-based system that you've created and bring it into flow state and have it become reusable block. And we think that that will offer a lot of value to folks who are very comfortable developing in the ROS ecosystem. They know all the tools, they know the libraries, they know the workflows. They want to be able to take advantage of all of the large set of libraries and hardware drivers that are out there, but they don't want to rebuild all of the other things that flow state offers them, and they want to be able to deploy what they built onto robots. So we think that, if you're in that position, here's an opportunity for you to take what you built, and instead of, rewriting in some other way, you can basically leverage all that, just basically bring it with you, and we can plug it in, and then you can take advantage of all of the other features of this intrinsic flow state ecosystem, those are in many ways complementary to what's been developed in the ROS ecosystem.
Yeah, that's great. And how do people actually use that? Do developers make this for themselves, or do you give through flow state and through intrinsic, do you give developers a path to commercialize ROS skills?
Yeah, so we're to give a concrete example, we've got a partnership that we've had for quite a long time with the robot manufacturer Kamau. And they, I guess, like you said, Universal is also starting to use ROS quite a lot. Kamau is also using ROS quite a lot, and they had developed some capabilities, some perception capabilities on their side that were using ROS, and they wanted to be able to leverage those inside flow state in order to develop applications that then they could turn around and take to their end customers. And so we were able to work with them, and that's what spurred the development of this specific ROS skill abstraction that we're talking about. We were able to build that and then work with them to, get their existing ROS-based perception system, bring it in as a ROS skill, be able to show that it works. This is actually a result that we showed at ROSCon in October in Odense, and now Kamau is in a position where they've got this system. They're able to take advantage of everything that they've built previously, and now they've wrapped it up in this new platform, which also supports their long-term deployment and support goals. And so now they can go shop that to customers and ideally find new business. That's the goal of all this.
Got it. That makes a lot of sense. Yeah. Okay, you talked earlier, you mentioned sim to real and using simulation, and you also talked about training in the cloud. So can you explain how just the various tools on the Intrinsic platform help to bridge that sim to real gap and support developers? And just some context for our listeners. There has been kind of various efficacies about like trying to simulate stuff and then bringing it to the real world. Things are always going to be different somehow between what you try and simulate in a cloud or on the computer versus what's happening in real life. Brian, can you just talk a little bit about how you're bridging that sim to real gap?
Sure. So, software simulation is super important in robotics. If you're going to you're writing software that's going to run on a very complex, in the early days, often very rare, sometimes very expensive piece of hardware. And so you need a good software simulation to be able to test it. And even after you've done that initial development, you need a good software simulation in order to be able to do continuous testing, right? You're going to make a change. How do you know whether it works? You need to be able to do a lot of that work in simulation. So in order for that to be useful to you, you need to be able to trust that that simulation is good enough. We've done a lot of work over many years on physics-based simulation. I mentioned Gazebo earlier. So at Intrinsic, we heavily use the Gazebo open source simulator, which is it's a 3D physics-based robot simulator. What we do in particular is we make sure, and this follows actually a long-running philosophy within the ROS ecosystem. We adopt this at Intrinsic as well, because there are many different ways that you could use simulators. The way that we use a simulator is we use it as a stand-in for the entire system, which means we run all or as much as possible of our entire software stack against the simulator. So when you're doing testing, you're running the application just as you would run it in the real world. You're running it against usually a cloud hosted environment. And then when you hit deploy, you're taking all that same software, it breaks down into Docker containers and so on. We're taking that same software and just dropping it onto an industrial PC that is then going to talk to the robot and the cameras and the physical versions of those things that we've been simulated. So having that, maintaining that level of interoperability, making sure that you're always running the same software in both situations, I think is really important. Have we closed this into real gap? No, right? As you said, there's always going to be some difference there. What we're always doing is pushing forward on how close can we get it in physics, in sensor generation, and this is an area where we know that we can't do it all. So we also look for areas, opportunities to collaborate with others. Gazebo has been very broadly used in the robotics community for a very long time. We rely on it, but we also look at what's happening in other ecosystems. The Open 3D engine, which is an Eclipse sponsored project that came out of some software that Amazon released, is very promising. Obviously, NVIDIA is at the forefront of doing photorealistic sensor rendering. And so, we're always open to figuring out how do we take the best of the tools that are available at the time and then use those either in a whole system simulation or in particular components in order to improve the performance that you need.
Yeah, that makes a lot of sense. Thank you. I've seen a lot with the Isaac system from NVIDIA, for example, and kind of that whole omniverse, as you said, the photorealistic side of things. And it's also interesting to hear the physics-based stuff on the Gazebo side and how it all kind of comes together. Right. So, Brian, let's transition and talk a little bit about the future, if you will. And I'm going to ask you to put on your premonition hat here a little bit and do your best guesses. I want your kind of instinct or whatever your gut reaction is for these things. But my first question is, as the automation industry continues to grow, what are the biggest educational gaps we need to close in the next 5 years to prepare for the future workforce?
So I think that one of the biggest opportunities that we've got in front of us is to get more people to be engaged with and comfortable with robotics and automation. I think we're pushing in that direction in a really useful way. I look at some of the folks who I look at job applications I get today, and there are folks who have been working on their middle school robotics clubs. Right, that's a thing that didn't exist when I was a kid, and that's amazing. I think we need to push even more in that direction and have more people who are like, we want them to understand that these systems that they're working with, they're not just toys, right? I mean, they're engaging. That's one of the reasons I got into robotics in the first place, is making things move around physically in the world is just like fun and interesting. But what they're doing, especially when they're, let's say, as you're coming into the high school level and then moving into college, you're probably, for example, picking up ROS and using it to learn robotics. You're, in fact, using the same tools that the people out in the professionals out in the, quote unquote, real world are using. And so I think that, one of the things that we can do, let's say at the college level, is really to emphasize that, we have to learn the concepts, we need to learn the tools, but also we can get those young people solving more real world problems. Some of the best new interns and new hires I've had over the years are folks who have come through really strong internship or co-op programs where during their education, they've had the opportunity to take a break for a summer or even a semester and go and sit with a company and get the experience there of solving a real world problem. And there's just nothing like that experience to prepare you for going out into the world and, working on real problems.
Yeah, that's a fantastic answer. We had a guest recently on the podcast. Her name's Kathy Walker, and she runs this institute. It's called ECAMI, and it stands for East Kentucky Advanced Manufacturing Institute. And essentially, her mission through that organization is to reskill and upskill Appalachian coal miners into advanced manufacturing jobs for the future. And she has an amazing 100% placement rate. She gets everybody into jobs with people like Lockheed Martin and other major companies. And so it was just a big testament to that. And she does that through really practical and applied applications. As you said, she has a Haas technical center there where they're learning to do machining. She's a Universal Robots training academy there where they're actually using the equipment that you would use out in the field. So I think you're spot on, at least compared to the opinions of our previous guests. Yeah. Thank you. And so before we wrap up, could you share a personal moment in your career where education, whether it was either formal or informal, had a significant impact on your path?
If I have to pick one, I'll just say that I had the great good fortune when I was in middle school. We were in Georgia, in the American state of Georgia at the time, and my parents were in a position to support me in the summer to go to space camp in Huntsville, Alabama. And it's just the coolest thing in the whole world, right? I grew up in the 80s in the heyday of the shuttle program. And it was just amazing to get the opportunity to go and, pretend to train to be an astronaut and to actually meet some, astronauts. And I found that to be just fantastically compelling and inspiring. And I haven't so far gone to space, but as I mentioned earlier, NASA actually, they put some robots on the space station right now that run ROS. So there's some software that we built which has gotten there. But I can say that early experience of being exposed to the impact out in the world of technology, in that case through the space program, had a huge impact on me.
Yeah, my friends know me as a huge space geek. So you're talking my language here, Brian, for sure. I think the commercial crew program and all the recent advances we've seen have been very exciting, and that I'm looking to see how robotics and kind of aerospace comes together in the future. So Brian, thank you again for joining us today. I really appreciate it. Once again, Brian Gerkey, from the CTO of Intrinsic and former CEO of Open Robotics. Thanks for joining us.
Thanks, Chris. It's great.